Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Abdul Rahman, and I'm going to present about final year project 2, which is the title is Impact Mechanical Behavior of Cast Aluminium Alloy, the Effect of Artificial Aging. Okay, the main purpose of the project is to study the effect of artificial aging of aluminium alloy, which is the properties of its strength, toughness, ductility, and also its brittleness. Basically, aluminium 6061 is widely has been used in industry for a good weldability and also being used in an automotive industry or an aircraft industry. Due to its advantages of its properties, I've been decided to study about the properties of those points that I've mentioned before. Okay. For the extract, I randomly picked the temperature, which is 155 degrees Celsius, 175 and 205 degrees Celsius. Okay. For the introduction is I would say that generally aluminium alloys can be heat treated into a specific heat temperature, which is generally it can improve the mechanical properties, especially their strength, ductility, brittleness, and also improve the creep resistance of this aluminium alloy. Okay, the literature review I would like to highlight about the the vital importance, which is by Rick Robert on 1994. He said that some metals are classified as precipitation hardening metals. When a precipitation hardening alloy is quenched, its aluminium element will be trapped in solution, resulting in a soft metals. Then aging a solutionized metal will allow the alloy element to trap into a solution elements, which is to diffuse through the microstructure and form a new fine grain, which is called an intermetallic particles. Okay, these intermetallic particles will nucleate and fall out of solution and act as a reinforced phase, thereby increasing the strength of the alloy. The alloys may age naturally or artificially, meaning that the precipitate form at room temperature, or they may age in a furnace oven. Okay, the methodology is the first one you have to. Okay, the first one I get the specimen, which is a cube straight raw aluminium alloy from the industry. So I have to cut it as a sample preparation. I use EDM wire cut to cut into pieces and make a notch, a V-notch specimen, which is the angle is about 45 degrees Celsius, and the spec itself depends on the ASTM E23 and ASTM D112, which is the American Society standard. Okay, after the sample preparation has been done, the next step is undergo the solution heat treatment. The solution heat treatment, the temperature is about 539 degrees Celsius. Okay, for the solution heat treatment, there are some explanation that have been highlighted here, which is the temperature and the time. The temperature is actually it depends on the graph that have shown the age mechanism hardening, which is it depends on the thickness and also the width of the specimen. For example, my specimen is about length of 55 millimeter length and also width about 3.5 millimeter. So basically for this size of this specimen, the temperature of solution heat treatment is about 6 hours continuously. The 6 hours it actually depends on the hardness of the specimen. Before we proceed with the solution heat treatment, I've done with some hardness test, which is to identify the hardness of the specimen on every surface of the single aluminium alloy, to make sure that the hardness along the surface is completely distributed. So, which means that once the hardness is all the same on every surface of the specimen, it means that the solution heat treatment is successful, which is the right time is 6 hours. If not, you have to do it increasing the aging time for at least about 1 hour or 2 hours to make sure that solution treatment is successful. Okay, once the solution treatment is done, you have to firstly put up the specimen from the furnace and do the quenching. The quenching we have to put in the water. You just soak the specimen and just put into just a normal plain water for about 15 minutes before you're going. Once it's done, you just put the specimen into a room temperature, which is about 27 degrees Celsius. And then once the quenching is done, there is a step which is the very important one, which is the artificial aging. The artificial aging is I randomly pick the temperature three temperature, which is 155 degrees Celsius, 175 degrees Celsius, and 205 degrees Celsius. Okay, for the after I done the artificial aging, perform a mechanical impact test, which is it depends on the HTM DE23, and by the force of hammer is 50 joules. Okay. Once the impact test is done, we can get the reading of the absorbed energy and total absorbed energy that have been received by the specimen. Okay, once it's done, we will proceed to the microstructure analysis to see and to define what kind of fracture it is, whether it is a brittle or a ductility fracture. So from that, we can see the microstructure grain. As we can see in here, the 155 degrees Celsius, 175, and the 205. As we can see, at 155 degrees Celsius, we can see there is a lot of crack because at the early stage, the temperature is low and the time is about 6 hours. You can see the formation of the crack is widely appeared. So it means that it shows the characteristic of the brittleness of the fracture. And then for at 175, we can see there is about the ending of the temperature. We can see the formation of the brittleness